So welcome everybody to tonight's free prep hour, June 24th, 2019. My name's Scott Miller. I'm located in Durham, North Carolina, and I'm going to be your instructor tonight. I do teach LSAT courses and tutor here in North Carolina. I also do a lot of teaching online, teaching our online LSAT courses and tutoring online, things like that. I really like this Zoom online platform that we use now for online courses and for these webinars. Works out really well, so I hope you enjoy our session tonight. Little bit of housekeeping, a little bit of a public service announcement before we dive into tonight's session. So we do these free prep hours a couple of times a month. You can attend these live, like a bunch of people are attending live this evening, or you can watch the free prep hours that we have on our YouTube, previous recordings that we have on our YouTube channel. And we have a lot of other free options too. If you go to our website, I'm going to put a link in the chat window at the end of the session, a link to the free resources page on our website. And you can find a good number of resources there that'll help you prepare for the LSAT. If you are watching this from home on our YouTube channel, usually in the description, in the information underneath the video or accompanying the video, you'll find these same links. So if you want to check out these free resources yourself. And let's talk about what we're covering tonight, what we're discussing tonight. So tonight we're going to focus on the logic game section of the LSAT. And we're going to talk specifically about creating hypotheticals. We're going to use a couple questions from our Logic Games Challenge page. So Logic Games Challenges are some free resources that we have available on our website. And these are logic games that are created by our instructors. So they're not 100%, they're basically the same. In many ways, they're going to be exactly the same as what you're going to see in the logic game section on an actual LSAT. The same types of games, the same types of scenarios, the same types of questions. They're not just 100% equivalent to any specific game or any particular type of game that you would see on the LSAT. But they are a good way to practice the skills that you're going to need to do well in the LSAT on the logic game section. And again, we'll include these because you can, these are the games from our Logic Games Challenges are free. I think you have to create an account in order to look at them all. But you can create an account on our website and go look at these Logic Games Challenges and go look at the actual logic games that we are looking at tonight if you want to go back and review them, on your own or try these games on your own. And there's like, I don't know, over 30 games there that we've created that you can use to practice if you want. So this whole thing of creating hypotheticals, this whole idea of creating hypotheticals, what's that all about? So a hypothetical is one possible valid solution to a logic game. And I'm just curious, in the chat window while we're talking about this, if you would go to that chat window and let me know, like, how familiar are you with LSAT logic games? Just give me a few words describing, for those of you who are attending live tonight, in the chat window, give me a few words describing how familiar you are with LSAT logic games. Are you totally new to them? No idea what logic games are about? I've been studying for a while. I've taken the LSAT already. Just give me a few words in the chat window describing the first answer, love-hate relationship. Yeah, that's a really common answer. A lot of people feel that way. I've felt that way myself at certain times. What else? So some people who are fairly new, some people who are studying for a while. Okay. So we're going to look at a couple specific logic games and what they're all about, but we're going to focus especially on this idea of a hypothetical, which is one possible valid solution to a logic game, a solution that follows all the rules. And hypotheticals are really useful tools. So hypothetical is kind of like, it's not something you're directly tested on. The logic game section isn't directly testing your ability to create a hypothetical necessarily. But it's a skill that you need to master in order to do well in the logic game section. So we're talking tonight about like an individual specific skill that you want to master and you want to get really good at. That's what we're focusing on. And along the way, we'll talk about, a little bit about logic games in general and how to approach them. But, when we talk about creating a hypothetical, creating a single possible valid solution to a game, it's kind of like if you're taking an advanced math class, like you're taking a calculus class or advanced algebra or something like that, and you think about like adding two numbers together. So you're probably not going to be like in an advanced math class, calculus class, or something like that. You're not going to be given a question where all you have to do is add two numbers together. But if you don't know how to add two numbers together, you're probably going to have a hard time with an advanced math class, right? I hope that makes sense. So, or kind of like if you play a musical instrument, like you'll spend a lot of time practicing chords or scales, and if you're going to, you're going to concert, or if you play guitar and you're going to go play at the local bar on Saturday night, you're not just going to sit there and play scales, right, or play chords. That's not really like what people want to see. But if you don't know how to play these scales, you don't know how to play chords, you're probably going to have a hard time playing a whole song, right? So it's kind of the same thing with hypotheticals. This isn't directly what you're doing when you play a logic game, but this is a skill that you need to know how to do. You need to know how to be able to create a single valid solution or a couple of solutions that match a certain criteria. You need to be able to do this if you're gonna do well in logic game sections. So that's what we're focusing on tonight. And when are you going to do this? When do we actually create hypotheticals? When we're answering conditional questions, those questions that begin with if. That is a time when your ability to create a hypothetical quickly and accurately it's really the key to success. When you're testing individual answer choices, if you get into a situation where you have to test out a certain answer choice to see whether it is the correct or incorrect answer to a question, and if you're doing something called framing, if you've been taking one of our courses or using our self-study materials, or if you've read our logic game strategy guide, we talk about this thing called framing, which is kind of an advanced logic games technique. It's not something that you necessarily would do for every game, and it's not something necessarily that everybody gets into, but it is a really useful, it's kind of an advanced technique, but it can be a useful technique at times. And everything that we talk about tonight is basically the foundation for how you build frames. Like once you have that initial split, if you're familiar with the idea of framing that we talk about, once you have that initial split, you know what the initial split is, and you're trying to create those additional diagrams based on that split, then basically you're creating hypotheticals. You're doing exactly what we're talking about tonight. So these are all the situations where what we talk about tonight will apply. So to start to really dive into this, let's play a logic game. I'm going to show you the setup for a logic game, and I'm going to ask you to create a diagram. So if you're really totally new to logic games and you have no idea what this is all about, then just read this little story that appears on the screen and see if you can make a few notes or draw some diagram or some pictures that to you represent what's going on. If you're familiar with logic games and how they work, you've been practicing for a little bit, then you should know what to do here at the beginning when you see the initial scenario and constraints for a logic game. So I'm going to give everybody just a couple minutes to look at this and do your diagram if you're familiar with that. If you're not familiar with that, then just take a look over the scenario and try to understand what's going on here. Okay, so we've had a couple minutes to look this over. Let me know in the chat window, like 1 through 5, how well do you feel like you understand what's going on here? 1 means, yeah, I understand it really well. 5 is, I'm really confused. So 1 is, yep, I'm all over it. 5 is, wow, I just have no idea what's going on here. Just curious in the chat window. Okay. All right, a little bit of a variety here. Okay, so what we're going to do, you know, when you see one of these logic games, when they show you one of these, you're going to read through this little story. This little paragraph at the top is what we call the scenario. The bottom we call the constraints. You're going to read through this and try to just get a basic understanding of what's going on. And I'm not going to go into too much detail about like exactly how to diagram a logic game, because we have other free prep hours recordings on our YouTube channel that go over this in a fair amount of detail. So I'm just going to kind of go over this quickly, our process for setting up a diagram to understand the game and to see understand these rules and the relationships. So this particular game is about ordering. They tell us that these 7 different varieties of beer are going to be tasted one at a time and consecutively. So that means this game is all about figuring out the order in which these beers are tasted. It's an ordering game. So we're going to write out the elements, the letters L, M, N, O, P, Q, and R. And then we're going to put down a number line. We're going to write this on our paper. Right, write this number line. And our whole objective here, what the questions in this game are going to ask us about, it's all going to be about which of these beers, which of these elements is going in what order. So we have our basic number line here, our basic board set up. And now we're just going to diagram these rules, represent these rules visually diagrammatically. So O must be the third beer. We put O in third. There's exactly 1 beer tasted between N and Q. So we put N with a little space in between N and Q. This, when I look at it, tells me, okay, the box around it tells me this is a fixed relationship, a definite relationship. And that little space there, that little underscore tells me exactly 1 in between N and Q. So is that right? What do you guys think? Does this all look good so far? Everybody agree with this? Give me an okay in the chat window, a yes if this all looks good. Give me a no if you have a problem or confused with any of this. Okay, people are saying yes. Shaylin, good point. Shaylin said, N must be first, then Q. The answer to that, Shaylin, is no. N doesn't always have to be first. This rule actually doesn't tell us anything about the order of N and Q. It just says they're exactly 1 beer in between. So Shaylin, you get 1,000 points. The points I give away during free prep hours are not good for anything, so I give them away very generously. Shaylin gets 1,000 for noticing that this isn't actually a totally accurate representation of this second rule. We actually need something like this. It's either N a space and Q or Q a space and then N. This would be an accurate way of representing this second rule. So you got to watch out for rules like that. Some rules are going to tell you about the order of 2 elements in an ordering game. Some rules are just telling you about the distance between them. And you need to really read these rules carefully and make sure that it's you got to make sure that you're understanding it specifically. So, or correctly. Sunny's saying, after reading the third rule, wouldn't N have to be first? So it says either Long Lake or Pumpkin Pale is the 5th beer tasted. I'm not sure. So either L or P has to be 5th. That's how I diagram that rule. Now you're saying because of that, it means that N has to be first. Can you, Sunny, if you want to, it's up to you, but would you like to get on the microphone and explain what you're thinking there about N having to be first? Or maybe if you don't want to get on the microphone, then you can put it in the chat window. That's up to you. But if you want to, you should see a little button at the bottom left corner that lets you unmute your mic. Oh, you thought it said O, not Q. All right. Yeah. Okay. Sorry. Yeah. I see what you're saying now. Okay. Yeah. Okay, good. So we're straight on that. We are clear on that. So no, N doesn't have to be first. This is Q, not O. And yeah, that's an O, not a Q. 2 separate things. All right, so that third rule does say either L or P is the 5th beer tasted. So we put L/P in 5 to indicate it's one or the other. We're not sure which. And now this last rule maybe is a little confusing. Either Pumpkin Pale is tasted before Roundabout or Moon Rune. I would love to know which of our instructors came up with this game. Somebody who likes beers, I imagine, and IPAs, but they came up with these fantastic names. Anyway, so either P is before R or M is before N, but not both. So this is one of those complicated rules that has a few different moving pieces, and we need to really, so one of the things, if you take a class with me, one of the things you're going to hear me say, one of my corny jokes you're going to hear over and over again is, it's a joke, right? Or it's joke or saying or words of wisdom or whatever you want to think about it, however you want to think about it. But the joke is how to eat an elephant. And the punchline is one bite at a time, right? And so anytime you see a rule that seems a little bit confusing in a logic game, it's really helpful to break it down into individual pieces. So either P is tasted before R, or M is before Newberry. So let's just look at that first part. Either P is before R or M is before N. And notice that I'm putting these dashes in between them. I'm not just, I see somebody like putting in the chat window. Now this doesn't mean, and this, I think this is a good point. I'm looking at what somebody wrote in the chat window. You're putting like P right before R, but keep in mind when it says before, that doesn't mean immediately before. If it's immediately before, then they'll say immediately before or immediately after. So that's why we're using this little dash here. This tells me that P is somewhere earlier than R, but I don't know how far. I don't know the distance. So that's another thing you have to watch out for in logic games is watch out for rules. Like the logic games are very specific. If it just says before, that means we don't know how far before. If it's immediately before, they'll say immediately before. But this is what the first part of the rule tells us. Either P is before R or M is before N. Okay, great. But not both. So what does that mean? Well, if it means P is before R, then M can't be before N. So since this is an ordering game, since there are no ties, it's exactly in order, then if M can't be before N, that means N must be before M. So, you know, there are a few different ways to represent this, but what I would probably do is just, you know, put the combination that has to be true together over here on one side of my OR, and then the other combination over here. So P has to be before R, or M has to be before N, but not both, meaning if P is before R, then N is before M. If N is before M, then R is before P. And that's how I would diagram that. How you guys doing with that? Let me know in the chat window. If you're here joining us live tonight, let me know in the chat window how all this looks. This is the basic board setup and the diagram of the rules for the game. Okay. So again, it's a good game to think about because some of these rules it's easy to get hung up on some of these rules, and you do have to be really specific when you're reading rules. One of the things I always say is, you know, success on the LSAT, it's a time test and you do have to work efficiently, but it's not all about always going as fast as possible. And especially if you find yourself making mistakes when you're notating the rules, then I would definitely recommend, like if you're misreading some of these rules or getting confused about them, or if you're notating them in a way that's not really accurate, just remind yourself to slow down a little bit when you're reading the rules and notating the rules. Taking an extra 10 or 20 seconds or 30 seconds to notate the rules correctly will pay off when you get to the questions, rather than like racing through as fast as possible and making a bunch of mistakes, especially at this point. That's not going to do you any good. So if you're familiar with our Manhattan Prep 4-step process for logic games, what we've just done is first, we've pictured the game and started our diagram, chosen our diagram. Then we've notated the rules. And the next thing we're going to do is make inferences. So inferences are things that are not explicitly stated in the rules, but must be true based on the rules. And I'm curious, does anybody see an inference here? Does anybody want to share in the chat window? Do you see any inferences that we can make in this game based on these rules? Like anything we could add to the diagram that must be true based on the rules, things that we know for sure. Give everybody a moment to look at that. And if you have anything you want to share in the chat window, go ahead and put it in the chat window. Q and N can't be 1 or 7, cannot be 1 or 7. It's absolutely correct. Ryan, do you want to hop on the mic? You should see an unmute button if you want. Totally up to you. If you don't want to get on the mic, that's fine. But if you want to unmute your mic, if you have a mic ready and you want to unmute your mic and explain why can't Q or N be 1 and why can't it be 7? Or just put it in the chat window if you want. Either way. Does everybody see that? Everybody see what Ryan's talking about? Like, oh, okay. We're fixing it. July, you see, yeah. Okay, it looks like you guys are getting this. Yeah, okay, I think you guys are getting this. I see a lot of people in the chat window chiming in. I think people are getting this. So if I put N here in 1, then Q has to be, I have to have exactly 1 space and then Q, but that can't happen because O is in 3. So N can't be there. Q also can't be there. And same thing on this end, right? I know L or P has to be in 5. So if I put an N or a Q in 7, then I've got to put the other one here in spot 5. So that's not going to work. Yeah, no problem, Ryan. No problem. It looks like I'm seeing in the chat window, it looks like some people are getting the hang of this. So we're just going to, you get 1,000 points for a correct inference. And we're just going to keep on rolling with that. So yeah, that's a definite inference in this game. We know that N cannot be in 1, Q cannot be in 1, N cannot be in 7, Q cannot be in 7. And so if you think about this little block we have, we call these chunks. Chunks are really important in logic games because it's a definite relationship. We have this definite relationship between one element, N, and then its buddy, Q, and there has to be exactly 1 empty spot, or 1 spot with not empty. It's going to have another element in it, but exactly 1 spot in between. And there are only a few spots where this can go. I can have N or Q in 2 and the other one in 4, or I can have one of them in 4 and the other one in 6, right? So there are only a couple, chunks tend to be really important in logic games. You really want to pay attention to them. And because they can be very restricted. They can be very restricted. And so noticing these chunks, paying attention to these chunks, and noticing when they're very restricted in terms of, because of other elements on the board, they're restricted in where they can go. So notice that either way, there are basically only 2 positions for this chunk. It's either going to go in 2 and 4 or 4 and 6. So either way, no matter where this N and Q chunk goes, I'm always going to have one or the other, N or Q, in 4. So that's another inference that we can make in this game. Either N or Q has to be in 4. If I have that chunk in 2 and 4, I'm going to have N or Q in 4. If I have it in 4 and 6, I'm going to have that chunk there. I'm going to have one or the other in 4. So no matter where I put that chunk, and again, so these, in an ordering game, you're very often going to have these, we call them chunks, 2 or 3 spaces taken up by a certain number of elements. Sometimes it's more than that. Sometimes it's 4 or 5 taken up by a set of elements. And those are really important. They're very restricted. So we know either N or Q has to be 4th. We also know something else here that we could add to our diagram, which is that either Q or N, whichever one is here, N or Q, the other one is either going to be in 2 or in 6. So these are all the inferences that I can make, the inferences that I can add to this diagram. And, this is always an important step in logic games. You may not, now, if you didn't see all these and you're thinking, wow, I'm not sure if I would have found all those, it's okay. You want to look for them. You always want to take a few moments after you set up your initial diagram to look for these kinds of relationships. Look for these kinds of things that must be true, inferences, things that we can deduce based on the rules, and then add those to your diagram if possible. And we're focusing on things that must be true, right? In every solution to the game, any valid solution to the game, I'm always going to have N or Q in 4. And whichever one is there, the other one's going to be in 2 or 6. I can never have N or Q here. I can never have N or Q in 7. So that's what we're focused on, the things that are consistent, always going to be true. So now we've set up our diagram, we've notated the rules, we've made inferences. The next step, so now you're thinking, all right, we're ready to answer some questions, right? But the next step we always emphasize is something called the big pause. And this is a step that a lot of people skip, and it can be a reason why you might struggle when you get to the questions. So we do just a couple things in the big pause. We look for what I call unruly children, elements without rules. I'm going to do a quick look at all my elements and see, are all these elements covered by one of the rules? And the answer here is yes. L is covered by the L or P in 5 rule. M is down here in this rule. N is here in the N and Q rule. O, we have a rule about O. We have a rule about P. We have rules about Q and about R. So I don't have any elements without rules. If I did have an element without rule, if I did have one of these elements, if I saw that one of these elements was not covered by any of the rules, what would I do? What would a good thing, somebody tell me in the chat window, what would be a good thing to do if you saw an element that was not covered by any of the rules? Yeah, circle it. Sonny, you're exactly right. So if for some reason, if L wasn't included in this rule, L wasn't covered by any rules, I'm just going to circle L on my paper. Why are elements without rules so important? Why do I care if there's an element without rules? Anybody have any ideas about that? Anybody want to put something in the chat window? Why are these unruly children, these element without rules, important? If there was one. There's not one in this game, but if there was one, why would I want to circle it? Why do I care? Floaters, yeah, that's another nickname that we have for them. I call them unruly children. Some people call them floaters. So they're very free. They're unrestricted. They're the most unrestricted things in the game. They can go anywhere until we have some other information at the outset. As far as we know, they can go anywhere. And so the other thing we want to think about is, what's the most restricted thing in the game? And we sometimes call that like the most valuable piece, or what's driving the game. So these are two things you think about in the big pause. Minimum. Look for any elements without rules, circle them on your paper if there are any, and then think about the most restricted thing in the game, which I'm going to say probably in this game is this NQ chunk. That's really what's going to be driving the game, the placement of this, either in 2 and 4 or in 4 and 6. Very, very restricted. We don't know if N's first or Q's first. We don't know the order, but it is really very limited. I mean, you could say L and P are limited too. One or the other has to be in 5. But whichever one's in 5, the other one seems really, really unrestricted. So these are two things you always want to think about before you go diving into the questions. What do I have any unruly children, elements without rules, and what's the most restricted thing in the game? And this is also where we would think about frames. I'm not going to talk about frames. I think we've talked about frames in other of our free prep hours. You can check out our YouTube channel and check out recordings on logic games where we talk about framing. But I know there's a free prep hour that I did on logic games a few months ago. I can't remember off the top of my head exactly when we did this, but there is a free prep hour that I did on logic games that covers frames. So you can check that out if you want to know more about frames. But this is the point where we would think about frames. But let's circle back to what our topic of the evening is, which is hypotheticals. Single valid solutions to the game. So a valid solution that follows all the rules. Now I'm going to say one thing at this point, which may be obvious to some people, but it's not obvious to everybody, and I want to make sure it's obvious. There is never going to be just one single solution to a logic game. That's not what this is all about. Like, it's not all about, okay, now I have this diagram and I understand all the rules. I need to figure out what the one solution is. That's not what we're doing here. There could be 7 different solutions to this game. There could be 10, 15, 20 different solutions. I've seen logic games before that have like 20 different possible solutions. So we're not worried about trying to find the one solution to the game, but we're also, something that people often do at this point, which I want you to break this habit if you have it. People will often try at this point to figure out as many possible solutions as possible as they can, right? So once you have some kind of diagram on your paper and some kind of understanding of the game, what you'll see people do a lot is on their paper just write out different solutions. So, okay, if I have P first, then I guess 1, 2, 3, 4, 5, 6, 7. Okay, so if P first, O has to be here, and then I guess that means L has to be in 5. Okay, so then I can have N before M, and so let me put N here, and let me put Q here. And people just will start writing down multiple scenarios and trying to figure out as many different solutions as possible. If you do that, stop. Stop. There is, again, when we talk about framing, there are certain very specific situations where you might write down a couple of extra diagrams representing a couple of specific situations. But that's not what I'm talking about here. You know, you don't want to, and I don't know, maybe everybody here, maybe nobody here does this, but I'm going to say this just in case. Your goal at this point of the game is not to figure out any possible solutions or every possible solution. That's a rabbit hole that you can drop down and just burn up a lot of time in a logic game that you don't need to do it. You don't need to figure out any complete solutions before you go and answer the questions. So this is not where hypotheticals come into play. At this point, before we look at questions, we're not going to try to figure out as many possible solutions as possible, or as many possible solutions as we can. You don't have to figure out any complete solutions at this point. Where we are going to use hypotheticals is when we get to the questions. And so I mentioned before conditional questions, if questions. So maybe you've seen questions like this, questions that begin with if roundabout is tasted first, and then they ask you something else, and then they give you a bunch of answer choices. So this is a situation where we're going to create a hypothetical. And the way we do this is you're not going to pollute, you may know this already, but you don't want to draw this on your initial diagram. We're not going to pollute our initial diagram. One of our instructors calls this your treasure map. You don't want to draw all over your treasure map. When we're going to test this scenario that we're giving, roundabout is tasted first. In order to test that out, I'm going to draw a separate diagram somewhere on my paper. So let me just draw 1, 2, 3, 4, 5, 6, 7 spaces down here on my paper, away from my initial diagram. And then this is tells me about R being first. So okay, let me put R first. That's what I'm being asked about. And then anything that's a definite, a constant from my initial diagram, I'm going to put, like O is always third. So let me just put O third here. That's something I know for sure. So this is how I would start a hypothetical, a temporary diagram. I have some specific thing that I want to test. I want to know what happens if roundabout is tasted first. So now what I'm going to do is look at these things that I have on my diagram, especially R, this condition that I'm testing. And now I'm going to go over to my initial diagram and scan my initial diagram. Do I have any information about that space 1 that R is in? No, not really. I just know N and Q can't be there, and they're not. R is there. So I keep looking, and what rules do I have that deal with R? Oh, I have this one down here. If P is before R, then N is before M. If N is before N, then R is before P. Okay, so I have R before P. That is the situation that I have. So I also know that M has to be before N. Okay, cool. Well, that's useful information. M has to be before N. Okay, so now what? Well, the other thing that I know is I know that I'm going to have N before Q or Q before N. So let me test this out. Let me try this out. Now, if M is before N, there's actually something else I immediately know in my diagram. If M is before N, then I can't have N in spot 2. I know this. I can't have N in spot 2 because if I put N in spot 2, there's no place for M to go. So I've found a rule dealing with R. It tells me M is before N. And then I look at this, M before N. Does that give me any new information that I can put on my diagram? Yeah, it means that N can't go in 2. So now, what else do I know about N? Again, I'm scanning my diagram, and oh yeah, N is in that NQ chunk. So that's an important piece, right? We know that's an important piece. So let me add that to my diagram. That NQ chunk is either, well, now there's only one place that it can go, right? It has to go in 4 and 6. But I don't know if N is first or Q is first, so that's fine. Let me just draw both those possibilities on my paper. Okay, so now I've gone from just creating one diagram, now I'm creating 2 diagrams. Okay, that's okay. So I also know that L or P has to be in 5. So let me just add that. L or P has to be in 5. And okay, what else do I know? So M has to be before N. Oh, well, if M has to be before N, then in this bottom scenario, N is here. So the only place for M is here in spot 2. And the only place for M up here in this top scenario is also in spot 2. That's the only way I can have M before N. Okay, well, this is pretty cool. So just by putting R, just by drawing this diagram, putting R in spot 1, and then saying what rules are triggered by having R in spot 1, I know this bottom rule is triggered. That gives me some new information. M has to be before N now. And then I think, okay, what rules, what other rules involve M or N? Oh yeah, the big chunk here. Well, let me add that information to my diagram. What does that tell me? Oh yeah, N and Q have to go in 4 and 6. Let me draw that. And now I'm thinking, okay, well, who's left? Who's not? I have an empty space here. Who's on my diagram? Well, I'm going to have either L or P in spot 5, and I don't really know anything about L or P. I know that, well, P has to be after R, but it's going to be no matter what. R is in first. So I guess whichever one, L or P, is not in spot 5, whichever one's not there is going to be in spot 7. So I could add that to my diagram. Either P or L is in spot 7. Okay. So awesome. I've just created 2 not totally complete solutions because I don't know about L or P. I don't know which one's in 5 and which one's in 7. So these aren't complete solutions, but they're pretty complete. And they're representing what I know must be true. There are only 2 possibilities if R is in 1. The top one here and the bottom one. Those are the only 2 possibilities. And in each of these possibilities, I've got a lot of stuff figured out. And I'm also keeping track of what could be. I'm keeping track of the must be's and I'm keeping track of the could be's. That's what a good hypothetical does. It shows you for any situation what must be true and what could be true. So I'm curious, in the chat window, like I just talked my way through this, but I really want you to notice what I'm doing. It's a very step-by-step process. It's a very methodical process. All I'm doing is adding something to, I'm starting with some initial seed, some initial condition, and then I'm just scanning my diagram and saying, hey, what rules are triggered by that condition? Oh, that gives me a new piece of information about M and N. Do I have any rules dealing with M and N? Yeah, I do. I have another rule dealing with N. Okay, what does that tell me? Does that give me anything I can add to my diagram? Yes, it does. And then continuing on from there. So it's very step-by-step. You're adding things to your temporary diagram, to your hypothetical, and then you're just scanning, looking through your original diagram to see if any rules are triggered. It's kind of like ping pong. You're going from your temporary diagram over to the original diagram, and then back to the temporary diagram and back to the original diagram, adding as much as you can, as much information as you can to this temporary diagram until we come up with what's here on the screen. And this is all just based on being asked, what happens if R is tasted first? So I want people to tell me in the chat window, how long do you think, maybe if you practiced a little bit, if you got a little bit of practice with this, and I asked you to do this on your own, you came back here like a couple weeks from now and I said, hey, we're going to do that beer tasting game again. And I showed you this. If roundabout is tasted first, what do? How long do you think it would take you to draw what we have on the screen down here? Would it be 10 seconds, 30 seconds, a minute? Just in the chat window, take a guess. You don't have to know exactly, but I'm curious how long it would take you to create this hypothetical, these 2 possibilities, solutions, if R is first, just following those steps that we just followed. In the chat window. A minute, 2 minutes, 30 seconds to a minute? Okay. Yeah, a lot of people say, it may take me a couple minutes, may take me a minute. So let's see why we would, maybe between 1 and 2 minutes. Okay, well, what's the value in doing this? Is there any value in actually doing this? So the answer is yes, because if this was an actual hypothetical question, if roundabout is tasted first, which one of the following must be true? And if I did all of this before I looked at anything else, so just based on this first part of the question, I do all this work, I spend a minute, let's say a minute and a half doing this work. And now I go back to my question and say, which one of the following must be true? So if it must be true, then I'm looking for the thing that happens in both of my scenarios that I created. It has to be the same in both of these diagrams in order to be something that must be true. Okay, well, R is in first, but that's not going to be the correct answer because that was the thing that they gave me, right? O in third is not going to be the correct answer because that was one of the rules. So the only other thing that must be true is M in 2. And I can quickly look through my answer choices and I see that M is the second beer tasted. Boom, I have my correct answer in like 5 seconds. So yeah, I'm suggesting that you take a minute. And even now, if it like takes you 2 minutes, all right, take the 2 minutes, practice this. Because what I'm telling you is if you practice this technique, if you get good at creating hypotheticals, if you practice this, you'll get to the point where you could do what we did down here in 30 seconds to a minute. And then you've answered the question in like a minute, minute and 10 seconds, or maybe under a minute. So this is one of the cases when we use hypotheticals. Hypotheticals are the approach that you use for a conditional question, a question that begins with if. And I love these questions. I love these if questions, these what we call conditional questions, because they give me a chance to practice this process of creating hypotheticals and then seeing how to use them to answer the question. So if you guys have any questions about that, fire away in the chat window. But if not, then let's try something else. Let's try clean this up a little bit, and we will try this scenario. If pumpkin pale is tasted first, so I'm going to give everybody a couple minutes, minute or two. What would you do with this on your own paper here, sitting at home on your own paper that you're working with? I was teaching a class last night, and one of the students had a little whiteboard, little like small whiteboard that they were doing their temporary work on. I thought that was fantastic because if you're studying for the LSAT, you might go through a lot of scrap paper. So if you take the time to do something good for the planet and go buy yourself a little whiteboard and use that for your practice, I actually have one here. These are great. Yeah, do something good for the planet. Save some scratch paper, save some trees. But anyway, on your scrap, that's all you have now is scrap paper, then go for it. What happens if P is tasted first? See if you can follow that process that we just followed of, okay, I'm going to add this to my diagram. Great, let me put P in 1. Now let's look at our diagram. What do we know? If P is in 1, what must be true? What do we know? And see, you know, does this come up? You come up with one solution, a couple different solutions. What happens if P is in 1? I'm going to stop talking now and let you guys work on this for a little bit. All right, I'll give you a little hint. Somebody already put it in the chat window. L is in 5. So, you know, again, scanning my diagram for rules that deal with P, the first thing that I see is L or P has to be in 5. Well, P is in 1. That means L has to be in 5. So I'm going to add that to my diagram. Okay, now what else do I know? Do I know anything else if P is in 1? Do I know anything if L is in 5? Again, just scanning, visually, looking through my diagram, looking for the L's and the P's. Where do I have L's and P's? Oh, P has to be before R. Shaylin, yeah, 1,000 points. So P has to be before R. So let me, like, I'm not just going to keep that in my head. I always joke and I say, when I'm playing logic games, there's nothing in my head. My head is empty. And it's kind of a joke, but it's true because I write things down. I'm not going to, like, at this point, I see that this rule is triggered again. P is before R, so N is before M. I'm not going to try to remember that. I'm going to write that next to my temporary diagram. N is before M. That's a new piece of information. I can't place it right on the diagram, but it's a useful new piece of information. So let me write that down. Okay. What else? Yeah, O is in 3. Yeah, 1,000 points, Ryan. I know O is in 3. Yeah, like it might seem obvious. Actually, I'm glad you said that, Ryan. It might seem obvious, but yeah, I want to add the obvious things to my diagram, especially if I'm stuck. If I'm sitting here right now going, okay, N is before M, but what does that mean? Where does N go? Where does M go? All right, let me add what I know for sure to my diagram. I know N can't be last, right? So you add anything I know. All right, N and Q must be 2 or 4. Or 4 and 6. Deanne, yeah. So you guys are putting some good stuff in. And like at this point, if I'm feeling a little bit stuck, then what do I know? Okay, so I know I'm going to have n in 2 and q in 4. That's one possibility. I could also have q in 2 and n in 4. That's another possibility. Or I could have n in 4 and q in 6. Or like I'm coming up with a bunch of different possibilities here. This is starting to maybe look complicated, but maybe it's not too complicated. Maybe if I don't worry about it, maybe if I don't sit here and go, wow, this is getting to be a lot of diagrams, maybe I'll just draw these. Let me draw what I know. Okay, so I know in each of these cases, O is there. I know L is there. And now, so I have looks like I have 4 different possibilities. If P is in 1, it looks like there are 4 different possibilities. So take a breath. Does R have to be in 7? Well, let's find out. Let me just focus on one of these at a time. Okay, so PNOQL, that's my bottom diagram so far. Well, who's left? I have M left. I know M has to be in N, and M has to be after N, so that's fine. M can go in 5 or 6. And who else is left? Okay, I have R. R has to be after P. Yeah, that's okay. So let me put R here. Now, they don't have to be in this order. It doesn't have to be M in 6 and R in 2nd. So what I'm going to do is use a cloud. I'm going to put a little comma between them, and I'm going to draw a circle around them. And that's to remind me that it doesn't have to be in that order. R doesn't have to be in 7. M could be in 7 or R could be in 7. That's why, and again, in hypotheticals, you want to keep track of what must be true, what you know for sure, and what could be true. So little things like slashes, either ors, or clouds, use those to your advantage, because you wouldn't want to just put M in 6 and R in 7 and then go look at this, a minute later and think that it has to be that way. It doesn't. M or R can switch. So now let me go to my next one. No, I'm doing how to eat an elephant one bite at a time. I'm just doing these one at a time and saying, what do I know? Okay, so same thing here. In my second scenario here, P, Q, O, N, L, looks again like, okay, I just have M and R left, and all I know about them is they've got to be here at the end. Like there are only 2 places for them. They're going to be here in the end, and that's fine. I just don't know in what order. Okay. So now I'm going up to this next diagram. I have P, a space, O, N, L, Q, and then an empty space for 7. Okay, but M has to be after N, so M has to be in spot 7. Who's left? What element is left? R. R's got to be in 2. Let's go up to the next one. Same thing. I have P, an empty space, O, Q, L, N, an empty space. Okay, what do I know? M has to be after N. That means R is over here. So this is kind of a wackadoodle crazy conditional question. You don't very often see, like there are a lot of conditional questions where there's only one possible solution. They'll give you a scenario like this: if pumpkin pale is tasted first, and there's actually only one possible solution. And you only end up drawing one of these little diagrams. I see quite a few where you, like the last one we did, where you have to draw 2 scenarios. Every once in a while, there will be one where you have to draw 3 or 4 scenarios to represent every possible world where P is tasted first, like this. This would be a really complicated conditional question. But again, what if I've practiced, like in terms of practicing and learning how to create hypotheticals, I love this question. This question just gave me an opportunity to create 4 possible solutions to the game. These are the 4 possible solutions if P is in 1. But again, all we're doing is applying this process that we talked about earlier. I'm putting P in spot 1 and then saying, what do I know? What rules are triggered by that? What rules are triggered if P is in spot 1? And I'm just, again, scanning my diagram for that information. Oh yeah, this bottom rule again. Okay, let me put that here on my paper. Okay, well, what else do I know? Yeah, I'm kind of stuck. Well, let me write the things, let me write the things on my diagram that are always going to be true. Let me put that in there, the things that I know for sure. And then you got to deal with the uncertainty. And if you get to this point where you feel kind of stuck, that's why in the big pause, when we said it's really good to recognize what the most restricted thing in the game is, because notice here, when we got a little bit stuck, what I did was think about this restricted piece, this NQ chunk, NQ or QN chunk. And okay, take a deep breath, just write out all those possibilities on the paper, and then start working through them one at a time. And I think even in a complicated situation like this, I think if you practice this, if you practice the art of creating hypotheticals, the ping pong game, right? Add something to your diagram, to your temporary diagram, look back at your initial diagram and see what rules are triggered. Add that information. Now look back again, see what rules are triggered. If you get stuck, either look for the most important thing or just say who's left. What elements haven't I added to the diagram yet? And that can give you useful information. And again, I think with a little bit of practice, somebody who's practiced this a little bit could probably create this, all four of these scenarios in maybe it might take you a minute, might take you a little over a minute, maybe a minute and 20 seconds. But again, if I've created all four of these scenarios, now I know exactly what's going on if P is first. It's going to be one of these four scenarios. All right, so now what's this crazy question asking me? The 7 beers could be tasted in how many different orders? Oh, this is an interesting question. Okay, so let me go count. I have 1, 2, 3, 4, right? But remember why I said you got to keep track of what must be true and what could be true, what elements can move around. So I'm noticing these clouds I created, these circles I put around M and R. That reminds me that, oh, they can switch. So I have 1, 2, 3, 4 possibilities, but these last two each have 2 possibilities. So 1, 2, 3, 4, 5, 6 different possibilities. These top 2, and then each of these bottom 2 represent 2 different possible orders. So my answer here is C, Charlie, 6. Again, the whole thing is, yeah, I spent like a minute and 20 seconds. You know, if I just sat here quietly and not talked to you guys, maybe it would have taken me a minute to do all this work if I was looking at this question for the first time. Maybe a little bit more than that. But then when I look at the answer choices, boom, they're done, right? You know, yeah, it's 6, as long as I read my diagrams correctly. You guys have any questions about this? Questions, comments? Questions, comments, thoughts, opinions? Okay. So, you know, this is one of my takeaways. This skill, yeah, Ryan's saying I could have written out 6. Yeah, so when it's something like this with M and R in this bottom diagram where I put them in place and then I see, oh, it's just these 2 switching, I'm just going to, you know, if I can just put a quick circle around those 2 elements and not have to write out 2 separate diagrams, yeah, I'll do that. Where it's something more complicated that's going to have more impact on the diagram, like where does N go and where does Q go? Boy, there are 4 really different possibilities. N here, Q here, Q in 2, N in 4, N in 4, Q. Like those are really different possibilities for N and Q. So that's why I wrote out all 4. If I can keep it simple and just represent an option or an either or in one diagram with a little either or notation, I'll do that. If it's something significant, then I will write out the 4 different possibilities. Good question. All right, so we're getting towards the end here, but I want to look at one other scenario, one other possibility that you might run into, which is a little different from what we've been looking at so far. And that is some of these if questions, some of these conditional questions are going to give you a different kind of condition. They're going to give you something that you can't actually put on the board. So these last 2 questions we looked at gave us conditions that we can write directly on the board. Whammo. Draw out my number line, plop P in number 1, and then say, what do I know? So notice this is a little bit different. If Q is tasted immediately before L. So like, where do I put that on the number line? I don't. But I still do the same process. I'm still going to create a hypothetical based on that. So what I would do, again, I always start by just writing down whatever they give me on my paper, on my whiteboard. So I'm going to put Q before, it's immediately before. Remember I said that's important. You got to pay attention to that. So Q is immediately before L. So that's a chunk, right? I'm going to put a box around it because that's a definite relationship. That's not a sometime before, that's an immediate before. Okay. So then I'm going to say, all right, you know, same thing. I put Q before L. Well, what rules do I have that deal with Q or L? And I see my L or P has to be in 5. Okay, maybe that's going to impact something. But definitely my chunk here is going to impact it. So let me think. What is that going to look like? It's either going to be Q, L, N, or it's going to be N, a space, and Q, and then L. So these are my definite possibilities. It's one of two options. And again, all I'm doing, and notice I'm not keeping this in my head. I'm writing this on paper. I'm writing this down so I can look at it and think about it. So do I know anything else? Okay. I don't know. So can I fit this? Let's think about how I'm going to fit this on my diagram. What are my possibilities? So if it looks like the only way this is going to work, well, I know L or P has to be in 5, right? So let me try out some scenarios here. 1, 2, 3, 4, 5, 6, 7. So let me put the L in 5 and see what happens. So I could have Q, L, N, or I could have L, N, and then Q here. And I know I'm going to have O here. And so what does this mean? Let's take a look at this for a second. And again, I'm just writing down the immediate possibilities, the immediate implications that I see. So in this case, so let's think, like, what do I have here on my diagram? Well, I know this piece is important, right? The P before R and the N before M. So in this one, what if I put N, M before N? What's going to happen there? If I put M before N, then I have to have R before P, and those are my last two spaces. So I end up with a complete solution, right? RP. Okay. Well, what about here? So if I put N before M, if I put M over here somewhere in the beginning, then again, I have to have R before P. So there are only two spaces for R and P, and so R has to be before P, so I can put those there. Now, again, M and R, they don't have to be in these places, so I'll put a cloud around them. All right, so now, okay, great. I've come up with two solutions. That's pretty cool. Did I get that right? Make sure I'm not making a mistake here. I don't want to mislead you guys. Okay. So now, and again, we're actually getting towards the end here. But what I'm going to do is think about whether these are the only solutions. Is there something else here that I'm not considering? So like one example might be, I'm putting, QLN, right? This is the whole QLN scenario. Oh, I know what. I made a mistake in the top one. You guys I made a mistake here. This one actually isn't going to work because, you see the mistake I made? I put L here, and instead of putting Q in the right place, so I totally messed up the scenario. And that's okay, right? So if you make, yeah, thanks, Shaylin, you noticed that. So yeah, if you make a mistake, it's okay to make a mistake and just cross it out, right? It's okay to make a mistake and just cross it out. And you may end up doing that. You may end up creating a scenario and saying, oh, that scenario is not going to work. Just cross it out on your paper. You don't want to leave bad scenarios visible on your paper, so cross them out. So again, what I would do is, like, doing this the correct way, I could have Q, L. Now, actually, if I put Q here before L, and I have a space, so that space is going to be O, and then I have N there. And again, I'm going to do the same thing. Well, what else is triggered? So I guess I could have M before N. If M is before N, then R is before P, and R and P end up in the last spots. So is this the only scenario? Is this the only way this can play out? I could have N and then QL here and P here. That's another possibility, right? So if N is now, in this case, M has to be before N. There's nothing else I can do except put M before N. So let me put M over here in the beginning. And then if M is before N, R has to be before P. Yeah, okay, so it's M and R here in the beginning. put a circle around them. So you kind of see how this ping pong match works, right? This little ping pong match. What I'm doing is, again, this is a scenario, a conditional question, and a condition that I can't actually put directly on the number line, not right away. But if I write it down on my paper, just whatever they give me, I'm going to write it on my paper. If it's putting P in 1, I'm going to draw a number line and put P in 1. If it's putting, R in 4, I'm going to, put R in, well, R can't go in 4. If it's putting R in 2, I'll put R in 2, right? Whatever they give me, I'm going to put that on paper. If it's just putting two elements together, a relationship between two elements, then I put that on my paper. And then again, I think about the implications to that. I go over to my diagram, I scan my diagram and think, what are the possibilities now? What are the implications? Okay, only two possibilities. And then I can start putting those on, I can start diagramming those out on the number line. Once I get here, where I know, hey, there are only two possibilities. It's either going to be Q and L with N immediately after, or it'll be Q and L with a space before an N. Then I can just play those out, write those down on my paper. And I end up with 3, maybe 4 in this case. There might be one other one here, one other possibility that you would end up with. You can check that out yourself when you have time. I'm going to wrap up here because we are getting to the top of the hour. But I'll leave you with a little bit of homework to do, a little bit of a follow-up work to do if you want. So first of all, what we're really getting at here is not so much these individual questions that we looked at or these individual scenarios that we looked at, but the whole skill of how do you create a hypothetical when you're given a certain scenario. Right? And again, this is only one. We're just showing these conditional questions. This is just one situation where you would create hypotheticals. If you're given, if a question tells you or gives you a new scenario like this. There are other scenarios or other situations where I would create hypotheticals, like for this question. Each of the following could be true except, okay? So which of these could be true? Like if I wanted to, there are a couple different ways to answer a question like this. If I wasn't really sure what to do, one way I could answer it is just to start testing answer choices, right? Totally possible to just start testing answer choices. Each of the following could be true except pumpkin pale is tasted second. So let me test that out. What happens if I do 1, 2, 3, 4, 5, 6, 7, and I put P second? Okay, well, if P is second, I can test out a couple possibilities. I know O is here. I know L is in 5. So if P is here, then I must have to have, well, I could have R first. If R is before P, then M is before N. But wait a minute, I have a problem because if I put N here and Q here, there's no place for M to go. But if I put N here and Q here, there's also no place for it to go. So that's not going to work. All right, well, maybe I don't have to have R there. Maybe I can have, R somewhere after P. So maybe R is going to have to be somewhere over here then because I have to have P or Q here. Oops, and I'm actually going to have to put R in this case in last, because if P is here in second, then I know my NQ pair is going to be in 4 and 6. All right, so if P is after R, then N is before M. But wait a minute, that's going to be a problem because I have to put N here and Q here, or vice versa, and there's nowhere for M to go. So what I end up realizing by creating a couple hypotheticals is this just isn't going to work. So each of the following could be true except, no, this can't be true. This is false. If I were to test the other ones, Moon Rune is the first beer tasted. Okay, let me test that. 1, 2, 3, 4, 5, 6, 7. M is the first beer. Okay, what does that tell me? Then I have M before N, so R is before P. And so this is an interesting situation. I'm just actually gonna continue for a second. If you got to take off, then you can check this out on YouTube. But if you want to stick around for another minute, this is kind of an interesting situation if I'm testing B, because I have to get a little creative here, right? So what's going to happen if M is first? It seems like there are a lot of possibilities. And that's okay, because I can just pick one. I want to see if this could be true. Each of the following could be true, except. So can B be true? Is it possible for B to be true? So you might have to, if you're testing a situation, you might, to see if it could be true, to see if it's possible, you might just have to make an arbitrary decision. It doesn't matter exactly what the solution looks like. We just have to have a solution that works. So let me stick N here. And again, if I stick N in 2, what do I know? Q has to be here, going back to my original diagram. Okay, NOQ, that works. Let me stick L here, and then R has to be, if M is before N, then R has to be before P. Okay, so let me stick R here and P here. And yes, that is a possible solution. That works. That could be true. And what we end up doing is we find out that all the rest of these could be true. And so the correct answer is A. A is the one that can't be true. Now, this is kind of a labor-intensive way of answering these, what we call, yeah, good job, Dan, you got it right. This is kind of a labor-intensive way of answering these, what we call unconditional questions. This isn't giving us a new condition. This isn't saying, like, if Q is fourth, which of the following could be true except, like, it's just saying in any solution of the game, each of the following could be true except. And there are a couple different ways to answer these, or, there are different ways we can show you how to answer these questions, but one potential way is to just test answer choices. And I would say that if you're ever facing a question like this and you're not sure what to do, if you're going to try, you could just skip the question. It's only worth 1 point. So maybe I'm not sure what to do. A really good solution would be to flag this question and take a guess, a wild guess, and then just move on, right? Only worth 1 point. You don't want to spend 5 minutes trying to figure it out. But if I got comfortable enough with this process of creating hypotheticals, you could actually answer one of these questions in about a minute or a minute and 20 seconds just by testing out answer choices and figuring out which ones can be true, which one of these aren't going to work. What I'll say in terms of practice, maybe not in actual, under time conditions, you might not feel comfortable enough creating hypotheticals to be willing to, maybe you think it would just take you too long to test every answer choice. But what I will say is if you're looking at a game like this and you're practicing and you find a question like this, like if you go to our logic challenges, if you go and look at our logic games challenges on our website and you go to this IPA beer game and you see this question, go ahead and play the game timed and see how you do, but then go back and use questions like this as an opportunity to practice creating hypotheticals. So what I just showed you a minute ago is something you can do, not like worrying about how you would, you're not worrying about how you would answer this question on an actual LSAT. You're just saying, hey, this is a great opportunity for me to test out each one of these answer choices is a scenario that I can create a hypothetical for and test. And this is a great way to get better and faster at creating hypotheticals. All right, yeah, let me put 3, 4, 5, 6, 7. Let me put P in 2 and then figure out, can I create a diagram that works, a valid solution that follows all the rules based on that? Let me put 1, 2, 3, 4, 5, 6, 7. Let me put M in first and see if I can do that. 1, 2, 3, 4, 5, 6, 7. M in seventh. Can I create a solution that works for that? And this is just using questions like this, these unconditional questions that give you 5 answer choices that you can go ahead and test, is a great way to practice creating hypotheticals, practice this process that we talked about tonight, and get fast at it. So, you don't have to, each question on an LSAT or in a logic game, it's not just something that's a challenge for you to try to answer as quickly as possible and get to the right answer and be disappointed if you don't have the right answer. Questions are actually opportunities for you to practice these processes that you want to get good at, and these micro skills that you want to learn that are going to help you. When you combine these small skills together, like this process of creating hypotheticals with understanding approaches to questions like this, then you bring in all these skills together, and that's how you end up being able to answer questions and kind of be able to deal with whatever the LSAT throws at you. So just to kind of wrap things up, we went over by a couple of minutes, but I want to wrap this up. So think about some takeaways. Think about some things that you want to remember. Yeah, I'm looking at Chinua, what you wrote in the chat window. One strategy is to map out all the could-be true letters in the same slot from the initial stages. Yeah, again, that's going down the rabbit hole of trying to figure out all the different possibilities right from the start. I mean, you can try that, but what people often find is you spend a lot of time doing that, and then you run out of time and don't have time to answer all the questions. So I don't really recommend that any process where you're trying to figure out as many possibilities as you can right from the start. I mean, a lot of people try that, and there are, like I said, we talk about framing, which is a very specific process of testing out. It basically involves a situation where there are only two possibilities for the game. There are only two possible solutions to the game, or only three possible solutions, or some piece of the game that can only play out in two or three ways. And you can write those three possibilities down and then create hypotheticals that fill out the rest of that, and you know what can be true and what must be true based on that. And then, but you only end up writing down or testing two or three or four scenarios. That is something that's worth doing. Just trying to write out all the possibilities ends up being a little bit crazy. But again, try it. You know, like, don't take my word for it. You can try these things and see how they work. So I promised that I would, at the end of the session here, I would give you some information about our other free resources. I'm going to go ahead and put this in the chat window. And again, for those of you watching at home, this information should be included below the video on YouTube when this video appears on YouTube. But I just put in the chat window some links to our free resources, upcoming classes. I also put a link to our digital LSAT blog post. So you guys know the big change to the digital LSAT format is coming up in North America. If you're taking the test in North America, that's happening starting in July. We have a great blog post. You can go to our website, manhattanprep.com, go to our LSAT blog, and read our blog post about the digital LSAT. There's a lot of good information in there if you haven't read it yet, for anybody who's taking the July LSAT or any of the LSATs in North America coming up after that when they transition from paper and pencil to the digital format. A lot of other good free resources on our website besides the blog, our online forums, our logic challenges I mentioned. If you go to our free resources page, you'll see Logic Games Challenge. And again, you got to create an account and sign in to be able to see all the challenges, but you can go play the IPA beer game that we just looked at and try these questions for yourself. You know, wait a couple days and then go try this for yourself and see if you can apply these processes that we just test out. And see if you can apply the processes that we just, you know, the idea of creating hypotheticals, even if it's not a conditional question like the ones we looked at, can you apply this idea of creating hypotheticals to other questions that you see in that game? If you're interested in attending one of our classes, you know, there's a link to sign up for our classes. And if you, you can attend session one of any of our online or in-person classes for free. You don't have to sign up for the full course or pay anything to attend session one. You can attend as a free trial student. You get some, it's an actual class session. It's not like a, you know, it is a real, you know, 3-hour session one of our full 10-session course. And you get to attend that and check out how we teach things and our processes. Another thing, this is kind of an advertisement, a shameless advertisement. Our 5-pound book that we came out with earlier this year is a good resource. So if you're looking for an LSAT book to buy, our 5-pound book is a good resource. It doesn't have any actual LSAT questions in it, but what it covers is a lot of these micro skills, like we talked about tonight, like this individual skill of creating a hypothetical for a logic game. You're going to find a lot of stuff like that and a lot of explanations about our methods and a lot of good review tools in our 5-pound book. And yeah, it actually does weigh 5 pounds. So there's a little mini advertisement for that if you're interested. And if you don't want to, you know, buy a book, then like I said, check out our free resources on our website. There's a lot of good stuff there too. So that's a wrap for tonight. For those of you attending at home, thanks a lot for joining us. Thanks a lot for watching the video. For those of you who are joined us live tonight, thank you for joining us tonight. And hopefully we'll see you back here for another session coming up soon.